Welcome to this course. In this course, we are going to understand what Docker is, how this Docker orchestration platform can help the software developers to build containers, images, and use Docker containers. So let's get started. So our today agenda is going to be based on introduction to Docker, what and why containers, understanding Docker lifestyle and ecosystem, building Docker images, and how to build a Docker image using a Docker file, and what is Docker Compose. So, Docker is a leading open source containerization platform, and it has many terminologies like Docker images, Docker containers, and what these terminologies basically are. So let's start understanding about these terminologies. So Docker containers wrap up a piece of software in a complete file system that contains everything it needs to run the application. Isn't it amazing, right? So the code, runtime, system tools, system libraries, dependencies, anything you can install on a server, this guarantee that it will always run on your Docker container, and regardless of the environment it is running in, whether you use Python, Node.js, JavaScript, or any language you have, that your Docker application container will run. Isn't it amazing? So this helps the software engineers and developers to have multiple Docker containers, and in every Docker container different application is running. So it is basically supported natively in Azure, GCP, AWS, and many cloud platforms are using Docker containers. So to sum up, Docker containers are basically a container in which your whole application, your code, dependencies, and everything gets wrapped up and it runs inside a container. As you can see over here, that it's in a shape of container, your application runs inside a Docker container. We will understand deeply as we go in the next slide. So the Docker architecture. If you want to understand how the Docker architecture works, then we have a client side where I am the user and I want to build Docker, I want to run the Docker, and I want to pull some Docker images from the Docker repository hub, which we will see later on what Docker repository hub is. So let's get back to the Docker architecture. So we were talking about the client side. So a client is responsible for building, pulling, and running Docker containers. But how these Docker containers works? So we have a Docker daemon where we have the containers, and for that containers we have different images. So images corresponds to your operating system, whether it's Ubuntu, Windows, or Macintosh. So we have different images like Ubuntu, we can have Macintosh, and we can have any images available on the Docker GitHub repository. So the Docker daemon is responsible for the build, the pull, and the run for from the client side, and the containers runs inside in a virtual isolated environment, which means your containers are totally secured. They have their own system, their own network, and of course their own operating system with a virtual memory. So you can pull different Docker images from Docker GitHub repository, like Nginx image, Python image, or Macintosh or Ubuntu image. We will understand what images are. So this was a basic architecture of Docker, which can consist of a client side, a Docker daemon, Docker engine, and the containers and the images, and how to pull different images from Docker GitHub repository. So the semantics, we need to understand the semantics of the Docker containerization platform. So what is the difference between Dockerfile, image, and a container? So Dockerfile is basically, it defines a source image and architecture and commands to execute to build a Docker image. So it defines image to build, which is the Docker build command, and a Docker image is basically images that are stored in a registry or a repository and are immutable copy of the application. It represents the basic information about a repository about a code, source code. That is what an image is. Then we have a Docker container, and inside this running container you have a Docker image. Then running different images, we have different commands, and for those commands we will be understanding in the next lecture. Now we have a Docker CLI, which stands for Docker Command Line Interface, where you have available for the Linux, Windows OS, and different operating systems. So this Docker CLI lets you to see which containers, which images you have pulled, how many containers are currently running, and how much memory is being optimized by every Docker container. So Docker CLI helps you, gives you a simple UI interface to the users to see how Docker containers are running, how much memory they are consuming, and inside what the Docker containers are doing. Then we have two concepts of containers versus virtual machines. So containers are basically lightweight alternative to virtual machines. They are smaller, less expensive, faster to start up, and self-contained. So a simple virtual machines have different layers. It starts with the host operating system. Then we have a hypervisor, a guest operating system. It can be Ubuntu, Windows, or Macintosh. And then we have libraries, some dependencies, and on top of that we have the application side. So this is how the virtual machine is. In virtual machine we have different layers, and every layer has its own responsibility, and every layer performs every task that is assigned to. So virtual machine has the concept of hypervisor, and when it comes to containers, Docker containers have the Docker engine, container engine concept. So how the containers and virtual machines differ from each other is, in virtual machines we have virtualization concept that comes in the hypervisor, and in containers we have a Docker container engine that is responsible for running the Docker containers. So that is lightweight, less computational expensive, and it's very fast to run and build Docker containers on your local machine. And also Docker containers have also they have their own operating system, their own network, their own memory, and it's much secure than the other virtual machines, because Docker containers runs in an isolated environment and it cannot be uh, breached up very easily. Then a technical overview of Docker containers. So dependencies, every application of course has some, it has its own dependencies, which includes both software, services, libraries, and hardware, CPU and memory storage utilization. And every dependency has its own role and its own working. Then we have the concept of virtualization. It's a container engine, which is a lightweight virtualization mechanism which isolates these dependencies per each application by packaging them into a virtual container. It is also, as you can see over here, that shared by a host operating system, which process in containers are isolated from other containers in user space but share the same kernel with the host and other containers. It's much flexible and differences in underlying operating system infrastructure and are abstracted way in running the Docker containers anywhere in your repositories, or any in your current CI/CD continuous integration or continuous delivery platforms. So Docker containers are fast, they can run everywhere. You don't need to worry about whether the application will run or not. Once you have the Docker container running, you all your dependencies code and everything will goes inside that Docker container, and you can run that Docker container anywhere you want to. So there's no need to worry about uh, of whether the application will crash, whether there's going to any dependencies issue, or any other system crash issues. So this is what how Docker containers helps us by running every application in an isolated container environment. So how do they differ from virtual machines? So they have own dependencies. it has its own independent operating system, much flexible and much secure. So high levels of resource are used because it runs, as I have mentioned earlier, it runs in an isolated environment, and isolation for key virtualization workloads. So this is what Docker containers are, and in the next video we will understand how to set up Docker and what Docker commands we are going to use.